Before we have our lesson, let's have a review. This refers to a compound that contains carbon and hydrogen. The correct answer is organic compound. Number 2. This refers to a compound that has no carbon and hydrogen. The correct answer is inorganic compound. Number 3. Which of the following compounds is inorganic? The correct answer is letter D. 4. Which of the following compounds is organic? The correct answer is letter D. Is NaCl, table salt, organic or inorganic compound? The correct answer is inorganic compound. Now let's do this activity. Guess the word. Let's try to identify this word. We have our clues. These are the structural formulas of its kind. And it is an organic chemical compound composed only of the elements carbon and hydrogen. Very good. Hydrocarbon. Hydrocarbons consisting entirely of hydrogen and carbon. The majority of hydrocarbons found on Earth naturally occur in crude oil, which is made up of decomposed organic matter. There are two types of hydrocarbons: saturated hydrocarbons and unsaturated hydrocarbons. In this video, we will discuss saturated hydrocarbons. These are hydrocarbons that contain only single bonds between carbon atoms. Here are some examples. Saturated hydrocarbons are also known as alkanes. It can be subdivided into the following three groups: linear straight chain alkanes, branch alkanes, and cycloalkanes. The name of alkanes always ends in ane. We got ethane, propane, butane, and pentane. The general formula of alkanes is CnH2n+2. You need to familiarize the prefixes. For example, meth it means 1 carbon atom. Eth means 2 carbon atoms. Prop means 3 carbon atoms. But stands for 4 carbon atoms, and so on. Let's have our first example, methane. You can see we have here the prefix meth. Therefore, we have only 1 carbon atom. Okay? And it ends with A and E, so therefore it is an alkane. To identify the molecular formula, you're going to use the general formula, which is the CnH2n plus 2. You're going to substitute the number of carbon atoms. Let's put 1 here, so substitute 1, then another 1. Okay, so for letter C or carbon atom, we only have 1. You will write C. Okay, no need to write number 1 as your subscript, because writing the letter itself means 1. Okay, and for the number of hydrogen atoms, you have to solve it first. So 2 times 1, we got 2, plus 2, we have 4. Then you will write 4 as your subscript. This is the molecular formula for methane. Let's have another example. Propane. Check the prefix. We have here prop, and it means we have 3 carbon atoms. Using the formula, substitute number 3. Okay, and another 3 here. So for the number of carbon atoms, we got C3, and for hydrogen, we have 3 times 2, 6 plus 2, 8. 8 hydrogen atoms. Or this is the molecular formula for propane. Now, what if we have the molecular formula? How to identify the name of this compound? First step, check the number of carbon atoms. We have here 6 carbon atoms. We will use hex. Okay. Next step, we're going to check if it is an alkane or not by solving the number of hydrogen atoms using the formula. We will substitute 6 here. Okay. We were done with the carbon atom, so we will proceed to the hydrogen atoms. We will know if it is alkane if we have the same number of hydrogen atoms. 6 times 2 is 12, plus 2, 14. Therefore, this is an alkane. We will just add A and E. We have hexane. Another example, C8H18. Check the number of carbon atoms. We got 8. We will use oct. Okay. Next, we have to check if it is an alkane or not. We will substitute 8. The number of hydrogen atoms should be the same. If it is not, this is not an alkane. Okay, so 8 times 2, we got 16, plus 2, we got 18. So we have the same number of hydrogen atoms. Therefore, this is an alkane. Now, let's draw the structural formula and write the condensed structural formula of alkanes. Number 1, we got methane. Molecular formula, CH4. Now, what is structural formula? Structural formula consists of symbols for the atoms connected by short lines that represent chemical bonds. 1, 2, or 3 lines standing for single, double, or triple bonds respectively. Take note that the carbon atom needs to have a full octet. It means it needs 8 electrons. If you still remember, each bond is equivalent to 2 electrons. We will write 1 carbon atom. And how many hydrogen atoms? We get 4. Again, hydrogen is happy with 2 electrons, or duet rule. So this bond represents the sharing of electrons. This is the structural formula of methane. Now, for the condensed structural formula, it is written in a single line to save space and make it more convenient and faster to write out. In condensed structural formula, we do not need to draw the bonds. Okay? We will just identify the number of carbon atoms and the number of hydrogen atoms. In our structural formula, we only have 1 carbon atom. So we only have 1 C. And how many hydrogen atoms? We got 4. Then write the subscript 4. Okay, this is the condensed structural formula. Another example, we got butane. For structural formula, we have 4 carbon atoms. 2, 3, 4. Draw single bonds. Okay, and how many hydrogen atoms? We got 10. Make sure all the carbon atoms have 4 bonds in each carbon atom. Okay? Done for the second one. Okay, we have 4. Third one, let's add 2 bonds. We got 1, 2, 3, 4. Okay, so 1, 2, 3, 4, 4 bonds. 1, 2, 3, 4. Okay, for second carbon atom. The third carbon atom, 1, 2, 3, 4. And for the last carbon atom, 1, 2, 3, 4. Then how many hydrogen atoms? We got 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. This is the structural formula of butane. Now, for the condensed structural formula, let's try another color. For the first carbon atom, okay, here, we got CH3. Okay, 1 carbon atom and 3 hydrogen atoms. Next one, we got 1 carbon atom and 2 hydrogen atoms. Next, we got the same 1 carbon atom and 2 hydrogen atoms. And for the last one, and 3 hydrogen atoms. This is the condensed formula or condensed structural formula for butane. Or you can also write the condensed structural formula this way. Let's try another color. So it's up to you what way you choose to write the condensed structural formula. So we got CH3. Okay, how many CH2 do we have? We have 2, so you can put a parenthesis, then subscript 2. Therefore, we have 2 CH2. Okay, and then CH3. Another example, pentane. We have 5 carbon atoms. 1, 2, 3, 4, and 5. Okay, then draw the single bonds. Make sure each carbon atom will have 4 single bonds. Next, how many hydrogen atoms? We got 12. So let's try another color rather. Total of 12 hydrogen atoms. Now, for the condensed structural formula, for the first carbon atom, we have 1 carbon atom, and 3 hydrogen atoms. It's the first carbon atom. Next, for the second, we got 1 carbon atom, 2 hydrogen atoms. Next, okay, next we got same. For the last one, we got, oh, I don't have enough space here, but this is CH3. Okay. Now, we can write another form of condensed formula of this compound. Okay. And how many CH2 do we have? You can write CH2, okay, and parentheses, then 3, okay, because we have 3 CH2, and the last one is CH3. Okay.